So this next example, this final section, is really putting all of the ideas that we just talked about in the previous sections, and we're going to put them all together. Okay, so we have this example, so we have this function f of x equals e to the minus x squared over 2. We're going to do these 5 things. We're going to find its critical points. We're going to find where the function is increasing or decreasing, where the function has local max or mins, where we have the function concave up and concave down, and we're going to figure out the inflection points of f. Okay, so let's get started. So first we want to find the critical points, right? So this is really saying where is f prime equal to 0 and where is f prime undefined, right? So where does it not exist? And that's what it's asking for when it asks for critical points. So I'll tell you, this function really has a derivative everywhere, right? So we're not going to get anything out of this. So really we're only looking for where is the derivative equal to 0. Okay, so number 1. So the very first thing we need to do is figure out what the derivative is, right? So we're going to take this function and we're going to find f prime. Okay, so the derivative here is going to require the chain rule. So I'm going to do first the derivative of the outside function, which is that e to the power. And then the inside function is what's inside of that power, right? That minus x squared over 2. So the derivative of the outside function is going to give me e, and I'm going to leave the inside alone, right? So I'm going to rewrite that power. Okay, so that's the derivative of the outside function, leaving the inside alone. Now I need to multiply by the derivative of the inside function, which we said was this minus x squared over 2. Okay, so now we have that part left to do. So notice this minus and this over 2 part, those are just a constant. That's essentially like having a minus 1/2 out front. So I really just need to take the derivative of the x squared part. And if I do that, derivative of x squared is 2x. Okay, you can see I'm going to get a little bit of cancellation here. Right, so this 2 and this 2 are going to go away. So I'm going to get, in the end, that negative. I'm going to have this x and this e to the minus x squared over 2. Okay, so this is what the derivative is equal to. Okay, now that we found that, we can set that to 0, and we're going to get f prime of x, that's minus x e to the minus x squared over 2. Set that equal to 0. We're going to solve for x. So when we have something like this, we can set each one of these two pieces equal to 0. So we get minus x equals 0. We get e to the minus x squared over 2 equals 0. So this first one gives you x equals 0, right? That's the only solution to that. This next one actually is never true, right? So if you think about the graph of e to any power, it's never going to touch the x-axis, right? If you think about the graph of e to some number, so this shape, the shape of this graph is actually going to look maybe, so my guess is something like this, right? Okay. So it's never going to touch the x-axis, right? That's the point here. So it's never going to touch the x-axis. So this never happens, right? Okay, so there's no solution here. Okay, so that means the only solution that I get, the only critical point I have is this one right here, right? At x equals 0. Okay, so that's this part right here, right? So we've done number 1. Okay, so check. So now we need to do number 2. So we need to figure out where the function is increasing and where it is decreasing. Okay, so let's maybe flip the page here. So number 2. So for that, I'm going to do a number line, right? So I'm going to write down, on my number line, I'm going to put down my critical points. So whatever critical points you get in the next example that you try out, you should put those down. Here I'm going to write down the one critical point we found for our example, which was at x equals 0. Okay. So now let's rewrite what the derivative of the function was. The derivative of the function was minus x e to the minus x squared over 2. Okay. So if I want to find out where f is increasing, I need to figure out where is f prime where is it greater than 0? And if I want to find out where f is decreasing, I want to find out where is f prime less than 0. Okay, so I'm going to take some numbers from my number line, and I'm going to plug them into f prime, okay, f prime, and I'm going to see whether that gives me a positive number or a negative number, and then I'll know whether the function is increasing or decreasing. Okay, so if I pick a couple of test points maybe, so pick your favorite numbers, right? So at -1 here, maybe 1 here. Okay, if I plug those in, so let's do f prime of -1. Okay, so that's going to be -1 e to the -1 squared over 2, right? So try your best not to get lost in the minus signs here. This is going to be 1 times e. This squared is going to square that -1, so I'm going to get -1/2 here. Okay. And this number is positive, right? This is a positive number. So here I have positive, right? So the derivative is positive here. Okay. So if I plug in 1, right, the next test point, I'm going to have minus, this will be a 1, e to the -1 squared over 2. And this is going to be minus e to the -1/2. And this number is less than 0. Okay, so you can punch that into a calculator if you don't believe me. Yeah, but this number will be like less than 0. So I know this is negative right here. Okay, so that means my function here should be increasing. So it should be going up. And then it should be decreasing. And so it should be going down here. Okay, so you have an idea now already of whether x equals 0 should be a local max or a local min. Okay, but if we're trying to answer this question, we're going to write down f is increasing on the interval, so it's increasing all the way from -infinity. So we're looking at this whole part of the number line, right? So all the way from -infinity to 0, okay? And it's decreasing on this part of the graph. So it's decreasing on this part of the graph, right? So from 0 to positive infinity, okay? So from 0 to positive infinity. And we leave out the points at x equals 0 because that's one of our critical points, and it's really not increasing or decreasing at those points. Okay, so this answers question number 2, right? So check on number 2. Okay. Now let's look back. So number 3 was determine where f has local max or mins. Okay. So we essentially have already done that. Okay, so f has a local max. So if we think about it, local max and mins, we look for those precisely where the critical points happen. We only ended up with one critical point here, right? And that was at this point right here at x equals 0. Okay, so that's the only place where we could possibly have a local max or a local min. And we can see that, in fact, it's going to be a local max because the graph of the function goes up to the left of it and then down to the right of it. Okay, so we know that that has to give us a local maximum, right? Because it goes up and then down. Okay, so that means that we have a local maximum at x equals 0 and with value. So we can figure out the value by plugging in x equals 0 into our function f. So with value f of 0 equal to, okay, so let's look back real quick at what f was. So it's right here. With value e to the -0 squared over 2. Okay, so 0 squared over 2 negative, so that's all 0. So we end up with e to the 0. This is just 1. Okay, so f has a local maximum at x equals 0 with value 1. Okay, so that gives us number 3, right? And it really doesn't have any local mins because we didn't find any other critical points, right? x equals 0 was the only place where we could possibly have a local max or a local min, and we see from the first derivative test, so in part 2 here, that it should be a local max. Okay, so there we go. So part 3 done. So if we look back, so number 4 says find where the function is concave up and where it's concave down. And then number 5 will say what are the inflection points. So we're going to do something very similar to what we just did for parts 2 and 3. So number 4 here. So we're looking for where is the function concave up. Okay, so once again, we are going to look for a derivative, right? So this time we're actually looking for the derivative of the derivative, right? So here's f prime. We're going to take its derivative. That'll give us f double prime, and that'll tell us where we find that the function is concave up and where it's concave down. Okay, so let's take f prime and take its derivative so we can find f double prime. Okay, so f prime is minus x e to the minus x squared over 2. We're going to find f double prime now. Okay. So you should realize here that this is going to use a product rule because we have minus x times e to the minus x squared over 2. And it's going to use a chain rule for this part right here with the e to the minus x squared over 2. Okay, so we're going to do the product rule first. So product rule says take the derivative of the first function, that's this minus x, so that's minus 1, times the second function, e to the minus x squared over 2, plus the derivative of the second function, so the derivative, I'm going to write it like this, e to the minus x squared over 2, so derivative of the second function times the first, right, so times minus x. So now notice we already know what the derivative of e to the minus x squared over 2 is, right? That's what this was, right? That's what f prime was. Okay? So I'm going to write that in for the derivative of e to the minus x squared over 2. Okay? So we have e to the minus x squared over 2, negative because of that negative on top there, plus, okay, this derivative should be minus x e to the minus x squared over 2, and then times minus x, right? So times another minus x. Okay. So let's simplify a little bit. So this is minus e to the minus x squared over 2, and then multiplying this term and this term, we're going to get, so those negatives will cancel each other out. We'll end up with an x squared e to the minus x squared over 2. Okay, so this is f double prime of x. Okay, so now remember, we're looking for where this function is concave up or concave down, and that means really we're looking for where is the second derivative positive and where is it negative. Okay, so first thing we're going to do is we're going to figure out where is it equal to 0, so that then we can plot a few points on this number line. So maybe let me move the number line up a little bit. So we're going to plot where f double prime is equal to 0 on this number line, and then we'll figure out where it's positive and negative. Okay, so first we need to figure out where is f double prime of x equal to 0, right? So e to the minus x squared over 2 plus x squared e to the minus x squared over 2. We're going to set this equal to 0. Okay? So let's factor out an e to the minus x squared over 2. So we're going to got minus, so let's do e to the minus x squared over 2. When I factor it out of this first term here, it's going to give me a minus 1. When I factor it out of this second term here, I'm going to be left with an x squared. Okay, this equals 0. Once again, this gives us two equations, e to the minus x squared over 2 equals 0 from this term, and then this term gives me minus 1 plus x squared equals 0. And this first equation has no solutions, okay, because there's no x value that I can plug in that's going to give me e to the minus x squared over 2 equals 0. Right, so this first one has no solutions. This second one, however, we can do x squared equals 1, right, adding 1 to both sides. And then taking a square root and remembering to put in the plus or minus, we end up with x equals plus or minus root 1, which is really the same as x equals plus or minus 1. Okay, so now that means on my number line up here, f prime is equal to 0 when x equals minus 1, or f double prime is equal to 0 when x equals plus or minus 1. So those are the points I'm going to label on here. And now I'm trying to figure out where is f double prime bigger than 0 and where it's less than 0. So I'm going to pick a couple of test points. So one in each of these three little chunks of the number line, right? So maybe something over here. Let's do minus 2. Something here like 0. Something over here like 2. I'm going to plug those numbers into f double prime. And then I'm going to see whether it should be positive or negative. Okay? So let's go ahead and do that on another page here. Okay, so let's write down f double prime of x. Let's look back real quick. So it's minus e to the minus x squared over 2, and then plus this x squared e to the minus x squared over 2 term. Okay, so this is minus e to the minus x squared over 2 plus, so I've already forgotten. Okay, so x squared e to the minus x squared over 2. Okay, so we're going to plug in the number minus 2, we're going to plug in 0, and we're going to plug in 2. Okay, so those were the three test points that we chose. Right, so minus 2, 0, and 2. Okay. So if we do that, we're going to get minus e to the minus, so this is going to be a 4 up here over 2, plus minus 2 squared e to the minus 4 over 2 here. Okay, so this is going to give me minus e to the minus 2. That squared is going to take care of that negative, so this is actually plus 2 e to the minus 2. Okay, so here I have minus 1 e to the minus 2, and here's plus 2 e to the minus 2's. So that's equal to 1 e to the minus 2. And this is a positive number. Okay? So I'm going to go back here, and I'm going to put a little plus here, right? Because the derivative is positive there. Okay? Now let's plug in x equals 0. Okay, so f double prime, we're plugging these into f double prime. Okay, so here's 0. Oops. Okay, so here's minus e to the minus 0 squared over 2 plus 0 squared e to the minus 0 squared over 2. Okay, so this term you can see is going to go away, so that's plus 0. And then here we have minus e to the 0. So really in the end, this is giving me minus 1. Okay, and you definitely can see that that's less than 0. Okay, so we're going to go back to our number line, and we're going to write down a negative here, right? Because f double prime is negative. And now let's plug in x equals 2. Okay, so f double prime, we're going to plug in 2, our test point. Okay. We're going to end up with minus e to the minus 4 over 2 plus 2 squared e to the minus 4 over 2. This is minus e to the second plus 4e to the second. Okay, together this gives me 3e to the second. And that's definitely a positive number. Okay? So we're going to go back to our number line, and we're going to put a little plus here. Okay? So we can see that on this interval, our function should be concave up because the derivative is positive. And on this interval, again, our function should be concave up. Okay? However, on the little chunk in the middle here, so this interval right here, our function should be concave down, right? Because our second derivative was negative. Okay? So let's write that down in interval notation. Okay, so f is concave, let's maybe do up first, and forgive me for the abbreviation, right? Concave up on, so on the interval from minus infinity to minus 1, minus infinity to minus 1, union, so this union symbol, right, from interval notation, union this section from 1 to positive infinity. Okay, so from 1 to positive infinity. And it's concave down on the interval in the middle, right? So in the middle, it was from -1 to 1. Okay, and you can see that from our number line right here, from -1 to 1, we're concave down. Okay. Great. So now that gives us that fourth part of the problem. And then we are looking for one more thing, right? So we were looking for number 5 here, which was the inflection points. Okay. So inflection points happen where the function switches from concave up to concave down, or vice versa, concave down to concave up. And so if we go back to our number line, we can see that the function here is concave up, and then here it's concave down. So there's a switch that happens right here. And then we have the function is concave down to concave up right here. And so a switch happens right at this point here. Okay. So we can see that our two inflection points are actually these points that we found right here, right? So we have an inflection point at -1 and at 1. Okay, so we'll write that down. So we have two inflection points. We have one. So we have 2. One at x equals -1, and another at x equals 1. Okay. So now if you look at the graph down here, so this is actually the graph of f of x equals e to the minus x squared over 2. Okay. We can see, so our critical points that we found, so here's -1, or actually our only critical point was this one here. So this is our critical point. Okay. And you can see we have a local maximum there. That is what we found. Our function is increasing on this part of the graph and decreasing on this part of the graph. Our function is concave up. So that's not where it's concave up. So it's concave up right here, and it's concave up right here. Okay. And it's concave down in this middle section. And you can see the inflection points happen right here at 1 and right here at -1. Okay, so you can see from the graph all of the things that we figured out, right? So the local max, the places where it's increasing, decreasing, the places where it's concave up and concave down, and the inflection points. Now you try all of this with this next example.